So I'm Manoj. I work with Java development tools, and I work at IBM, supporting the Java releases primarily. Today's talk is about brewing patterns in Java. I know some of you, Hans and of course Stefan, of course, have been using these things regularly. But I just want to see how many of you are familiar with instance of patterns. Oh, Sebastian, of course. Yeah. Jans. Yeah. And how many of you have really used instance of patterns in production code? Wow, that's nice. How many of you are familiar with pattern switches? Did anybody use it in production code? Good, because it's still preview feature. So I want to ask you a question before we go further. Is this a valid code or not? Hans, you're not supposed to answer. We discussed it yesterday. So. Sorry? Valid.
The underscore got invalidated as an identifier in Java 9, I think.
Fantastic. So that's the answer is, of course, as usual, yeah. Depends. And it's okay in 1.7. There was a warning in 1.8, and it's an error in 9. So how does this relate to pattern matching? So just understand that they have been brewing patterns for quite some time, and this has been one point it was all about Lambda expressions, the JSA 308 type annotations, but hidden between these lines was this particular small thing. And we'll come back to underscore and see where it fits in the whole scheme of story. So this is the agenda. Fantastic agenda, right? We'll just talk about what. And the why and how is kind of intermixed. So as we go through why these patterns are there in the first place, the how is also will be explained, because we need to explain using the code structures. I see a lot of gray hair, so I'm sure that a lot of people would have used awk. How many of you used awk? Oh, nice. People without gray hair also using awk. So it had a fantastic feature, right? The pattern matching. You remember, like you have a pattern, it matches a pattern, and then there is an action associated with it. Say the token is IBM, it will print the line. Now, extrapolate the whole thing into a language which is typed, like Java, and what do you get? You get that pattern matching gets expanded to an applicability test, whether it's, because the type system comes into the picture, then you conditionally extract, we'll come to that, what exactly it means, and it binds the extracted result into a particular variable. So in this case, you have an instance of pattern. Well, all of you must be familiar with O instance of X. And what is new here is that little x, which is that variable that is there. If O is an instance of X, that's applicability test, conditionally extract into that variable little x and binds it, and then the action remains the same, x.print. One thing to note here is, there is a scope that is coming into picture where the X is applicable. The scope of X is applicable only inside that if statement, inside the block of the if statement. So it's a typed system, right? So now this is about a record. So I have another talk coming in a later point of time. So if you don't find yourself really tortured enough, you can attend that one also in the evening. But for now, the point is a record. And how many of you are familiar with records? Okay, so just understand it's a class. It's a class that has constant. So it is like X and Y are constant, and once you create that class, the value remains the same. But in the context of this, the applicability test, it will say that O instance of point int X, int Y. One difference you would see is that there is no variable out there. So there is a cast that happens internally to point and then these variables are extracted out. So it's not the point that gets extracted out, it's this x that is something one level deeper that gets extracted out. And I just want to show how the extraction is more explicit in such a pattern. So why do we do that in the first place? If I say it makes code simpler, I'm sure some of you may not agree, but it really makes code simpler. A lot of error conditions are missed out, and it makes the code less error prone. But is that the only reason? Answer is no. For that, we'll have to get into the object model. Java follows the object model, and the creators of the Java, they mentioned that it's more about fixing some of the holes in the object model, which in the first place could have solved some of these things. For that, let's understand what is object model and what does it provide. So it provides something called object creation. And how do we provide object creation? We use constructors. We take the description of an object's initial state, say int x, int y, and then create an instance of that particular class and give it back. So there's a linguistic support provided by Java for construction or aggregation. Now let's add inheritance out of it, onto it. Then you see that I have a shape, C equal to new circle, shape S new square, perfectly valid code. At the time of creation of this, I know C is a circle, I know S is a square. Now I start passing it around. I don't know, at some point I don't know whether S is a square or a circle, right? See, so what does aggregation provide? It provides specifics to general conversion. You give an integer, you give a string, etc., or you give a inherited upper class, and then what you get is you get whatever you ask for, say shape in this example. And this is more like an abstraction. And this becomes even more pronounced when you use these factory methods. I mean, I'm sure many of you must have used the factory methods, but you have shape and you have static constructors out there, which returns get circle, get square, etc. All return shapes. So I don't know whether it's returning a square inside get circle or a get square, but what I know is it's returning a shape. Again, we have a problem that we don't know at some other point in time how do we know what exactly it is. How do we convert general to specifics? And it's impossible? It's not impossible. It's, of course, you can use a type system, check for instance of for all of these things. That's one way. Or you can destructure using something like kind, using an enum. It's a circle or a square, or some of these things which we use very, very frequently. Again, it's on the type system. You will have to provide these things at the highest level. Sometimes they are unrelated. So these are the ways by which you can do a destructuring. So this is a kind of a whole in terms of not having a proper linguistic support, and this was one of the motivations for the pattern matching, as it will become clear. So how do we do that? If you look at the code, you can see that if you apply, this is a pattern switch where you are switching on a type. We are not switching on a value. We are switching on a type. Earlier, we are all used to switch I, case 1, case 2, case 3. So we are getting into a constant, and we are switching on a value. But in this case, we are switching on a type, and we are saying case, circle, whatever, case square, whatever. So this is kind of destructuring right from the language without explicitly having the instance of. Of course, the compiler internally does a lot of stuff. internally it will, I cannot say loop, but it kinds of looks at this, then if it doesn't go, it goes back. That's how the implementation, but let's not focus on the implementation, but at least from a Java native language support, this is what it provides. And we can even go further. We can say that on the right side is just, it's a switch expression, and the right side is just a constant, but we can even go further and extract the variables out of it. You figured that it's a type of circle, you can extract radius out of it or edge out of it. So, we can get greedier. We can say we can extract, using the methods we can extract things out of it, the static thing. So this is not implemented. The one which I showed earlier is in the preview stage, while pattern switches are again in the preview stage. So you should not be using the production code, but instance of is one which you can use in the production code. As of now, it will come out soon. We hope the pattern switches will become standard in the next version. We're hoping it's not yet, well, at least last time I looked, it's not yet there in the list, but I think it will be done because the third preview is done. Generally, third preview generally becomes final, but this time there were changes, and so we had one more preview. It's coming up. So what does destructuring provide? It provides better APIs. When I say better APIs, say if you have, you don't have to write too many APIs. Say if this is circle, then you do this. No, you can use directly the destructuring using the type. And it becomes more powerful when you think of nested structures and multiple return values. Let's just skip. This is a little involved example where I have an interface inode, and it implements in node and add node. If you notice here, there are two inodes, and there is one value out there. And if you see on the right side, we can switch on this composite structure, add node, and internally extract an int node, which is 0. Yeah, if you feel that it's complicated, just leave it. Just understand that there are cases where you can extract very specific nodes. Say this is a node which has the left operand as 0 and right operand we don't care. Or we can extract nodes which are just left and right operands, the general add nodes. Okay, so I think I'll stop at that. Yeah, sure, Enes. Yeah.
As far as I know, it would also only work if that node and in node are records,
What?
are records. Or does it also work for ordinary classes like?
No, at this point, this is not implemented.
Okay.
This is for records at this point I'm talking about. So, and of course, there are other rules that will come into picture because you need this one to be more specific than anything down, because the whole control flow goes like one. So it's kind of a loop which is guaranteed to proceed. So yeah, sure.
Just by looking at it, it would seem like so this is a pattern matching actually, but from the look of it, it would be like a call to int node 0. So this is in other code, this would be say like a method which is called every time, which would be having an impact, which is not equals only, but would be have a much broader overhead than it's like just some numbers equaling each other as they are now in the switch, for instance.
Okay, I understand the question fully, but to whatever extent, it's like it's not an internally you don't call this function recursively. We are looking at the types, but we'll go down the types and see we'll do a type checking, and then if it matches only, we will say that we'll say that this is the right arm of the switch to be taken.
Well, I mean, it looks very powerful, and I was wondering what kind of overhead comes with that. So if I have this in my code and it's called a lot of times, how how much impact would that have?
Yeah, so that's what, the overhead, a lot of overhead is done at the compile time. But there is definitely some overhead wherein you'll have to check the cases. And it returns the first case that matches. So if you have 10 cases, you can say that it will be in order of that much, order of n, how many cases you have. Yeah. So, but part of it is being done at the compile time.
Okay.
Okay.
So it's not that much overhead. It's not always at runtime.
No, it's not that much over, but I don't have a right answer for you in terms of the numbers because we have not tried it out. Yeah. And this is not yet implemented. Only the basic case record is implemented. The record pattern is implemented. That too, it's a preview feature that has come in Java 19. Which was released in September last month. So. And this is more of a future. I wanted to show how powerful it can be. Except syntax may change. So, how much time do I have? Okay. Now, does it mean that this is multiple return values? It looks like that, right? You are looking at the order of, it's always an instance of rectangle, and then we are kind of extracting length and breadth. So, is it multiple return values is a question, but it does, of course, returns multiple values in one way to look at it, but at the same time, there is the scoping also involved because these things are available only inside that. And there are further scoping rules which are a little more complicated, but the basic funda is, this is how it works. It's inside the scope where this expression is true. You can even have and of expression, and this and of expression and length greater than 0. In that case, the length will be available there. If it is false, it will not be available there. So that's one major difference between something in Python where you have multiple return values, tuples or something like that. I mean, it's record themselves are tuples, so can be thought of tuples of data. So that's about it. Now let's look at another aspect of it. That's about polymorphism. How do we provide polymorphism? We generally go to the type system and we say we can provide parametric types. Say we have generic type and use the same code for different types. Or the other way is define a hierarchy, the subtypes, and then the same code can be used. But what about trying to combine things which does not have to, we don't have to impinge the type system? What about we can have a data-driven polymorphism where it's an ad hoc polymorphism? So unrelated types. If you look at it, you can have the switch expression and you can have the which slide is things? Yeah. These are unrelated types, right? Integer, my object, structure. So you don't have to go to the type system. You don't have to say that this is there's a hierarchy. We can just use the user pattern switches and kind of use similar code for polymorphic kind of stuff. At this point, record is a big entry into the. It's like a constant class. I think some of you have used records, right? Sorry, can I have it? Yeah. And you used in production code? Yeah. Yeah. Oh, you can. It's available. It's a standard. So this one small thing at the top of it's a data class. It's a constant class, and the compiler will provide the entire stuff for you inside, and it's less error prone, and unless you really want to do something, you can do something about it. You can write your own code, but otherwise, this forms the basis for most of the pattern matching. And combined with that, you will have the pattern switches, which we have seen. Yeah, I think I don't have to go further into that. And then that's about the seal types. Anyone use the sealed interfaces? sealed type. So sealed types is something like you have a hierarchy and you want to bring constantness to the hierarchy. So you're bringing constantness to the class by using records. But at the same time, if you want to bring this constantness to the hierarchy, we can say that we seal this hierarchy. So when I seal this hierarchy, nobody else can add additional subtypes to that. So it is between final class and normal class, something like that. So here, for example, if I have a sealed interface element, I seal the interface element and by permitting only point and line to extend this interface. And then we have a record point and record a line. So I forgot to add that we should also have implements element in both point and line. So it's my mistake. And it's used in the major use of it is about in the switch expression, in the pattern switches, where if you notice there is no default statement, because it's like enum, right? You cover if there are 5 enums and you cover 5 enums in the case statement, then you don't have to have a default statement. And how does this help? It helps like what are the types available, what are the data types that is inheriting this element, and that brings some constantness from leeway for designing, thinking about what is available, what you should be doing, what are the types which you should be looking at when you are doing when you're coding. Any of you use your visitor pattern? Oh yeah, actually I am also. And what you see is our code. We have so many AST nodes. This is how we take any compiler. We take the source code, we make it into a tree, and so many abstract syntax. And how do we do this visitor pattern? Multiple ways. One, of course, using the accept. And the other way is we use a AST visitor, where that's a separate class, and whenever you want to do something, we just extend that and do whatever we want. Now, with patterns, this becomes kind of a little easier by you pick up the code like this, where you want to operate only on a couple of nodes, and we just use these kind of stuff. So I'm not sure whether it's really motivating for some, but I think this is a good use case. So we come, I think I'm closing earlier than I'm supposed to, but what is underscore? We have talked about underscore, and where is it in? This is going to come, it's going to come like something like in Python, where it's a don't care. You're returning a switch, and you're switching on a pattern of a point, but I don't care about the Y, I care about only X, so you can put underscore. So that's how the underscore got promoted, and he doesn't know about the promotion because we still haven't implemented yet. So that's going to come soon. So they have, these are the 2 excellent references from the makers of Java, and some of the examples are taken from this. And you can try it out. It's available in Java 19, whatever we have published, in Eclipse directly. Okay, that's it, unless you have further questions.